Hi all, welcome back. Today we're going to discuss the integumentary system, otherwise known as skin. So the integumentary system is super important. First of all, it's that first line of defense, and we'll talk a lot more about this. Um, but it also happens to be the biggest organ. So if you think about all the skin that's associated with your body, it's a huge amount of surface area. Okay. On top of it, it is an area that gets damaged quite often. And so it's important to kind of talk about that integumentary system in regards to what injuries might be expressed in there, what is the actual building pieces to it, and how, in general, how it works. Okay, so we'll talk about the epidermis, the upper layer, the dermis, the middle layer, the hypodermis, the kind of deeper layer, and then we'll even talk a little bit about how it's connected with muscles and things like that, and the components that occur within each one of those layers. Before we dive into that, though, I want to talk about just a case study. I like to either bring these in just so students can start thinking about, how does the integumentary system apply to your life, or how does it apply to just humans in general? And so sometimes it'll be an individual going to a medical center for an injury. Sometimes it'll be long-term care at a health facility. Sometimes it'll be like a medical report, something like that. And then we'll just talk through it and look at, different components of it. So in this case, we have a 34-year-old male who was hiking. He's got severe sunburns in certain parts of his body. He's got blisters on his arms, and some of them have burst and ruptured, and then his face and neck are sunburnt. And so he's fatigued, he's in pain, and let's look at what the backstory to this is. Okay, so a little bit of the history. The patient was hiking at high elevations in Mount Rainier. He did not apply sunscreen, believing that the cooler temperatures meant lower UV exposure. And he reports pain, swelling, and difficulty moving his fingers. Okay, so if we assess what's going on, so the assessment of the finding, we find out that his burns on his forearms, the blistered filled regions, okay, are second degree burns, okay, and his burns on his face and neck are mild and they're first degree burns, but vitals, in general, his vitals are good. His heart rate's okay, blood pressure, temperatures. I mean, they're not perfect, but they're good. It doesn't seem like the individual's in need of too much, except for maybe since he's in severe pain, maybe he needs some pain medicine, things like that. Okay, so now let's talk about what would the role of the nurse be. Okay, so what what role would a nurse have if this is the individual that's coming in and he or she is in charge of this individual? Maybe the first thing would be to assess the burn depth. Okay, so what regions of this individual's body are second degree burns, what regions are first degree burns. Okay, monitor for fluid loss. Okay, the individual has ruptured blisters, so the individual's losing fluid. The individual, okay, being sunburnt over a large portion of their body, increase their temperature a little bit, and so they probably were sweating also, and losing water to the environment. So probably need some fluids. So provide the individual some fluids, not just monitor the fluid loss. Okay, what else? Sterile wound dressing, of course. I mean, if you have blisters that are rupturing, okay, now that integumentary layer, that top layer, is opening up and releasing fluid, and that's a perfect avenue for things like bacteria to enter. Okay, so providing sterile wound dressings and pain management through maybe some pain meds or something like that. Okay, one thing that often we don't associate, maybe at least the general public doesn't associate with nurses, is their role in educating. Okay, the nurse is spending and making a rapport with this individual. Okay, and part of that rapport and part of that time spent can be spent educating the individual in a tactful way. Okay, educating the individual about how the higher the altitude, the actual higher the UV exposure is, and that even more importantly, to wear sunblock and to monitor your fluid loss, even in cooler weather. And so, just kind of general explanation of how those systems work. Reinforcing protective uh, pieces so they don't wind up back in a medical center for the same thing. So protective clothing, sunscreen, hydration, and then just reinforcing that hydration might be super important because this individual is losing fluid. So ensuring that this individual is drinking water while they're in the care of that nurse is pretty important. Okay. Provide support. Okay, so the individual, being a 34-year-old, might feel really embarrassed that they're in a medical center uh, due to severe sunburns that they could have prevented themselves. And so just provide them some support. Accidents happen, kind of thing. And then, apart from that, explain healing time, explain the potential for scarring, that kind of stuff. That's all kind of the role, just pieces of the role that a nurse would have in a situation like this. All right, so let's look at the integumentary system. So when you're inspecting kind of this organ, and we're talking about the skin, the hair, the nails that are all associated with kind of that outer surface of the body. Okay. A couple things about it. Skin is probably the most vulnerable organ that we have, and the reason why it's has high vulnerability is it's the first line of defense. It's the first line that's going to interact with UV radiation. It's the first line that's going to get bumped, bruised, cut. It's the first line that's interacting with viruses, bacteria. It's the first line that if a chemical is spilt or um, gets on your hands or feet or anything like that, that's the first line of defense. Okay, and so by far more medical treatments than any other organ the integumentary system gets. So lots and lots of medical treatments for this organ. Um, Fairly important. Okay, dermatology, as many of you know, is the scientific study and medical treatment of the integumentary system. All right, let's look at a little bit more. Okay, so the integumentary system, it consists of that skin, hair, nails, and the glands that are associated with it. And we'll talk about some of these glands that are important. Okay, it's the largest and heaviest organ. Okay, almost 2 meters squared, and depending on the size of the individual, and it weighs about 8% of your body weight. Okay, so if you take 8% or 10% and knock off a few, so if you weigh 180 pounds, 18 pounds, maybe 16, 17 pounds of your weight is skin. Okay, or integumentary system. Okay. Consists of two main layers, and we're going to talk about a third layer that is really not part of the skin, but it's an associated layer, and it's important nonetheless. Okay, so the first layer that we'll talk about is the epidermis. Okay, that's that outer layer, and that is what we call stratified squamosa epithelium cells. So squamosa, remember from when we talked about cells, squamosa are squished cells. Stratified mean they lay on one on top of another, so it's multi-layered thick, and epithelium being the outer layer. Dermis is connective tissue, and there's quite a few different types of connective tissue, and we'll talk about some of those, and we already discussed quite a few in previous lectures. Okay. The third layer, which is really not skin, but it's often just associated with it, is called the hypodermis. Okay, and that's the layer below the dermis, and often will have connective tissue that might be a little bit different type of connective tissue, but it provides kind of that connection between the dermis layer and the muscle that might be coming after the hypodermis. Okay, so let's look at just a cross section through some skin. Okay, so you got this epidermis layer. We already talked about those squamosal cells. You got this basal layer where the cells are alive. The upper layers, the cells are not alive. Okay, and they're being scuffed off. We have hair follicles that move all the way through the epidermis into the dermis, okay, where the root of the hair will be, or the hair bulb will be. You have glands that are associated with it. We'll come back and talk about some of these glands, like sebaceous glands. They're going to release sebum, and that's like an oil-like structure, oil-like substance that keeps the hair follicle oily and moisturized, basically. Then you have things like sweat glands that will move out and have a duct all the way out to the through the epidermis, and to provide evaporative cooling. You have muscles that are associated with the hairs. There's all kinds of things. Blood vessels that are going through there to provide nutrients. Okay, that epidermis layer has no blood vessels. So the blood vessels have to be in the dermis layer, excuse me, and that's what provides the nutrients and the oxygen for the epidermis layer. All right, so skin thickness. Well, it ranges from 0.5 to 6 millimeters thick. Okay, the thickness is mainly due to the variation in dermis thickness. Okay, so how thick is the dermal layer, that middle layer that we'll talk about? Okay. Now, there is often we will talk about thickness based on what we call thick skin or thin skin. And that's a little bit different. Okay, yes, again, the dermis is going to provide the the main difference, but there is a difference in the epidermis between thick skin and thin skin. The epidermis will have a different stratum, a stratum that we'll talk about later. Okay, but it has an extra stratum. So instead of 4 stratums, it has a 5th. Okay, and when we look at the epidermis, the primary thickness of the epidermis is the corneum. That is that outer layer that's scuffing off, and so that's kind of the dead material, the keratinized material that scuffs off. That's really what makes up the main thickness of the epidermis. The rest of this, so if we're talking 6 millimeters in size, maybe 5.5 millimeters is due to the dermis thickness, and then you get like a 0.5 due to the epidermis. Okay. Thick skin, though, these are skin areas that typically have high contact with abrasive environments. So the palms of your hands, the tips of your fingers, the bottom of your foot, the sole of your foot. These all have really thick stratum corneum layers, okay? And you won't see other things in those regions. You won't see sebaceous glands, you won't see hair follicles. You do see sweat glands, but they are missing certain things in that region, okay? And then thin skin, okay, it's going to have 4 epidermal layers and really covers the majority of the body. And has hair follicles, sebaceous glands, sweat glands, etc., and typically is 0.1 millimeters thick. Okay. So what's the function of skin? Okay, in general, skin resists trauma and infection. Okay, it's a first line of defense. Okay, and associated with skin in many regions are different types of protection against even bacteria. Protection against abrasion is keratin. Protection against bacteria, so antibacterial properties, dermicidin, defensin, acid mantle. These all provide places that bacteria, a lot of bacteria don't like to inhabit. Um, Other barriers can be barriers to water. Of course, that's a big one. We want to be able to evaporate, cool, but we don't want water to just soak into our body. UV light, harmful chemicals, all kinds of things. The barriers provide. One of the great and cool components of skin is that epidermal layer in the stratum basal layer, okay, is where we have the ability to synthesize vitamin D. Okay, so UV is, yes, harmful and helpful. Okay, the UV rays can allow for a molecule, okay, a precursor to vitamin D called 7-dehydrocholesterol to switch its shape. Okay, so UV comes in, it breaks bonds, and causes it to change its shape. So there's no enzyme, there's no protein associated with this. It's all driven by UV. And when that happens, okay, that molecule becomes vitamin D. Okay, and we will talk a lot more about the role that vitamin D plays when we talk about bone, and when we talk about how bones kind of develop and the need for vitamin D to synthesize bone material. Okay? The function of skin continued, of course. It's not just a barrier, but it also provides sensation, okay? Whether that be from touch, from temperature, from chemical, all kinds of sensation, and that really has to do with the nerves that are associated with the skin. Okay, so thermal regulation, you have this ability to regulate heat of the body by releasing heat or retaining heat. Okay, and so it also will allow for the sensation to know whether we need to constrict our vessels through vasoconstriction or dilate the vessels through vasodilation. Okay, so either we're going to constrict how much blood flow goes to that region or increase how much blood flow goes to that region. Okay. Other things like facial expressions. Okay, and so there's been lots and lots of research studied, our ancestors like chimpanzees and gorillas and orangutans and how their structures in their face, their muscles in their face, and what kind of facial expressions can they do, and then facial expressions that we do, and what muscles are associated with it. Can we tell when someone's sad, mad? Can you tell when someone's curious? These kind of things. Facial expressions are really important for lots of communities, even way before verbal communication. Facial expressions were really important for society.